Hola, hi, this is Al, your statistics instructor. Let's get to work. In this video, we will quickly review the concepts of expected value and variance for discrete random variables. Let's begin. So this is the first problem that I would like to solve in this video with you. Okay? So we have a discrete, clearly a discrete random variable. We have here that this variable assumes a finite number of values. Okay, so the values are 0, 1, 2, and 3, and the corresponding probabilities are 1 over 8, 1 over 4, 3 over 8, and 1 over 4. Okay, so we would like to find the mean, which, as you know, it's a numerical measure of center for this probability distribution. The variance is a measure of spread of variability with respect to the mean, right? The thing with the variance is that it's given in squared units. So that's why we take the square root of the variance and find the standard deviation, because that is going to give you a measure of variability in terms of the original units of the random variable of interest. Okay? So anyway, here I just want to remind you how to find the mean and the variance for a discrete random variable. Okay? Here we go. So let y be a discrete random variable. So we know that the expected value of that random variable y is going to be given by this, right? The sum over all y's of y times the probability that the random variable y assumes that particular value. Make sense? Okay, so in our problem, that is going to be just this: 0 times 1 over 8, 1 times 1 over 4, 2 times 3 over 8, and 3 times 1 over 4. Let's write that down. 0 times 1 over 8, 1 times 1 over 4, 2 times 3 over 8, and 3 times 1 over 4. Now let me rewrite these guys. 1/4 is the same as 2 over 8. That's 3 over 8, 2 over 8, right? That would be the same. Agreed? Okay, so what we would have here is 2 over 8 plus 6 over 8, right? Plus another 6 over 8. So that's just 14 over 8, right? So that would be the expected value. Okay. Or 7 over 4, right? Okay. So now, next, what we would like to find is the variance. Okay, so we know that the variance of a random variable y is just the expected value of y squared minus expected value of y, the whole thing, squared. Right? Okay. So now I want you to, well, that is an alternative way. This is not the definition, right? You know that the variance, the definition of variance would be the expected value of y minus its mean squared, right? But this is an alternative formula, right? It can be easily shown that the definition is equivalent to this formula. So let me use this guy, this alternative formula, to find the variance. And now let me remind you about something that you have seen before, that if you want the expected value of a function of a random variable y, let me call that generic function g, the expected value of g of y is going to be equal to the sum of all the y's over all the y's of g at y times the probability distribution of the original random variable y. Okay, so let's find the expected value of y squared. So in this case, right, it would be just y squared. Let me write down the formula. Okay, so it looks almost like the definition for the expected value of y, but what we're going to be changing is this, right? Instead of a y, we're going to have a y squared. Okay, so now let's find it for our particular case. So let me copy paste this, right? So 0 squared 1 squared 2 squared and 3 squared, right? Okay, great. So what we have here is just 2 over 8, right? Going to have 4 times 3, that's going to be 12 over 8, and 3 squared, 9 times 2, 18 over 8, right? Okay, so what we have here is 20 plus 12, that's 32. So 32 divided by 8, that's nice, that's just a beautiful 4. So that's the expected value of y squared. So since we want the variance, right, let me copy paste this. This would be just 4 minus, 4 minus this squared. So variance of y is just 4 minus 49 over 16, right? So let's find it. Let me do this so I can just copy and paste and use R. Let me clear this here. Okay. So 4 minus 49 divided by 16, right? So that's it. That's our variance, and we know that the standard deviation, right? Sometimes people refer to the standard deviation. The notation that they use is sigma of the random variable y, which is nothing but the square root of the variance of our random variable. So it would be just the square root of that number we just found. Okay. So square root of that guy. Okay, so very quickly, let's try and check using R that our calculations are okay. So let me create an object called y that contains 0, 1, 2, and 3. I'm going to be using the function c, which stands for concatenate, right? So we are combining these numbers. We're saving them in an object called y. Okay, so if we type the name of the object we just created, there we are. It is what we want, right? 0, 1, 2, 3. Now we need 1 over 8, 1 over 4, 3 over 8, and 1 over 4. So let me call that probs, if you will, as in probabilities. Again, I'm going to be using that c function. 1 over 8, 1 over 4, 3 over 8, and 1 over 4. Okay. So if we go back to our definition for discrete random variables, we just need these products, right? And we add them up. Okay. So it would be y times its corresponding probability, right? And we need the sum of those products. 1.75, so 7 over 4, I think we're right. Okay. Now the variance, how we found the variance? What we did is we found first the expected value of y squared, right? And then we subtracted the expected value of y squared. Okay, so let's find the expected value of y squared. That guy would be almost like this one, right? So now we want y squared times our probabilities, right? And what we want is the sum of those guys. Okay, so that's the expected value of y squared, so it's 4, and you know, since we had the expected value we found the expected value correctly, then our variance is going to be correct and our standard deviation will be correct as well, right? So it would be just, if you want, we could do it like this, right? Expected value y squared minus the expected value of y, which is this guy here, squared, right? Okay, so that's it. So just a quick reminder of the definition for the formula to find the expected value of a discrete random variable, and also the variance for a discrete random variable. And then we just checked our work using R, and what was very useful was that C function, that R command that helps us create vectors, okay, and the function sum, okay. That's what we did here. Well, that's it for now. Thank you so much for watching. Please take care and keep working hard. See you next time. Bye.